Hi, I'm Toby Tung, a research scholar with the Analytical Instrumentation Facility, or AIF, at NC State. Today, Rohan Dal, a postdoctoral fellow with the AIF, will demonstrate the Transmission Electron Microscope, or TEM. This microscope can give us images at very high resolution. First, we load the sample mounted on a TEM grid into the sample holder. The sample holder is a long rod that can reach to the middle of the column. We then plasma clean the sample to ensure we are not imaging dust or debris that could have collected on the sample. Plasma cleaning uses ionized gas, or plasma, to remove contaminants from the sample surface. We also always wear gloves to protect the sample from contamination. TEM must be performed in a very controlled environment. This room is actually a room inside a room. Thick concrete surrounds the room to prevent vibrations from affecting the instrument. Even small vibrations, like someone talking, can cause major changes at the atomic level. A change in temperature can also affect the sample. The radiative cooling panels seen here help to maintain the room at a constant temperature. This is the TEM. Let's briefly review the different parts of the microscope. At the top of the microscope is the electron gun. Electrons will be accelerated down the column to form a beam, which is transmitted through the sample. This is the cold trap. This trap will attract contaminants that could enter the vacuum system and make it difficult to maintain the appropriate vacuum. This is necessary to enable the electron beam to travel the length of the column. If other molecules are present, electrons will interact with them and never reach the sample. We load the sample here, into the goniometer. This is a microscope stage that can move in the X, Y, and Z directions, and can also rotate. This helps us control how the sample will interact with the beam. The electromagnetic lenses that help focus the electron beam are found inside this column. It is under vacuum. Here's where the image is projected. This phosphorus-coated screen produces the signal that will allow us to see an image. Below the screen is the camera that will capture the signal. To begin imaging the sample that we loaded, we first add liquid nitrogen to the cold trap. When working with liquid nitrogen, we must wear special cryo gloves that protect our hands from the very cold temperatures of the liquid nitrogen. Then we have to turn on the electron beam with an appropriate accelerating voltage. Next, we check some safety parameters of the instrument. We want to make sure that we have reached the appropriate vacuum and have an appropriate beam emission current that is not too high or too low. Next, we align the beam. This is essential to obtaining a high-resolution image. This is done by adjusting different microscope components. We can look here to see if the beam is aligned. If the beam is not aligned, we may see it wobble from side to side, or it may change diameter. After alignment, we can begin imaging our sample. The camera below the screen will collect the signal and send the information to the computer. As you can see, if we disrupt the environment, say by clapping our hands, we can see the distortions in the atoms that are being imaged. That's how sensitive it is. On the computer monitor, we can see our sample and save the image for further analysis. Today, we are looking at gold nanoparticles. Here we can see individual atoms. You must use a TEM to obtain this high of a resolution. We are also able to measure the size of a feature. Note the nanometer size of these particles. Rohan will continue collecting images from different regions of interest in the sample. This concludes the TEM demonstration. Thank you for joining us.